AI agents don't work alone anymore. They work as a team. And that's the direction the industry is moving forward. That's why companies like Microsoft and Amazon are investing heavily in orchestration platforms like Azure AI Foundry and Amazon Web Services. Most people still imagine AI as one chatbot, one prompt, one answer, but multi-agent systems work very differently. You now have layers of specialized agents operating together like a coordinated system. For example, sub-agents handle highly specific tasks using their own tools and environments. Their orchestrator decomposes the problem, routes tasks, executes workflows, and synthesizes outputs. Orchestration pattern layers determine how information flows, how agents collaborate, and how decisions get made. And this is where AI systems start looking less like chatbots and more like a distributed operating system. One agent may retrieve data, another may analyze documents, another may generate code, another may validate outputs. Their orchestrator coordinates all of them. That orchestration layer is becoming the real product because once models become commoditized, the competitive advantage shifts elsewhere. Workflow coordination, tool integration, execution reliability, memory management, retrieval architecture, system-level orchestration. The model generates tokens, the orchestration layer generates outcomes. All right, so what we're looking at here is a multi-agent system. And in this diagram, I'm going to talk to you about how we do things differently when it's a multiple agents working together to get the job done. The first thing to notice is that right at the top, there is something called the main agent, or otherwise known as the orchestrator. The orchestrator's job is to organize everything. It's going to receive some kind of response from the user through an HTTP endpoint. And what it's trying to do is sequence tasks based on the sub-agent's outputs that come in. So for instance, over here, we got sub-agent and sub-agent. These are specialists. They're designed to do specific things for this particular orchestration that we're doing. They may have specific tools. They may have specific MVC tools, or they may have a specific HTTP tools as well. One of the things that's very important is that the way they communicate with each other. We can have tasks that are sequential. So in this case, for instance, maybe the task of this sub-agent gets passed on to this sub-agent, which then gets passed on later down the chain. Or it may be parallel tasks. So in this case, we might have this agent doing a task and this agent doing a task simultaneously. One, it saves time. Two, they don't really depend on the output of each other to get the next task done. So as we move down, the response is structured through JSON and then append on to another sub-agent, which then communicates the information in a more user-friendly way to the user. It may be another HTTP endpoint that it gets sent to, or it might just be direct to the user, depending on the type of user interface. Looking over here, this is what we're working with. So sub-agent's job is to do specialized tasks with their tools, as we saw over here. The orchestrator's job is to decompose, route, execute, and synthesize the jobs. And so as we saw here, there's different types of orchestration patterns. We have sequential tasks, as we discussed, where one job of one agent is dependent on the other agent. So we need to feed the output of one as an input to the other. They can be parallel tasks where they're done at the same time, or they may be synthesis tasks where the entire output is structured, sometimes in a JSON structure, handed off to another sub-agent, which then hands off a more user-friendly response to the user.